Hi, I'm Jake Kapusta, the 3D Print Operations Manager here at Formlabs, and this is my Fuse1 workroom. Here, I have the Fuse1 and the Fuse1 to run SLS 3D prints from design to finished part. Today, I'm going to show you the process of printing this mixer clip, which is a component of the Fuse1 that we prototyped in-house on the Fuse1. Let's start with what the design looks like in our 3D print software, Preform.
Preform is Formlabs' pre-production software for both our SLS and SLA 3D printers. We have a specialized view for the Fuse1 build area that makes starting a print quick and easy. Here you can see the mixer clip design loaded into Preform. First, I rotate the part in an optimal orientation for printing, and nest a copy of the same part alongside in the inverse orientation. Next, I use the Array tool to duplicate these parts in a grid, and then duplicate that grid vertically along the Z-axis. This allows me to densely pack the build volume and print as many parts as possible in one job. In this case, I can print 102 mixer clips at once, which you can see in the model list here. In the detail menus above, I've calculated the print time, which should take about 52 hours from start to finish. I can also see the total amount of nylon powder for the job, and if I hover my mouse over this figure, I'll see a more granular view of the materials cost for the individual part. From here, I'll use my print menu to select the printer by name and send the print job to the Fuse1 via my local network connection. Once I've loaded the print onto the Fuse1, I select the job via the touch interface and start the print. The user interface runs through a series of quick pre-print maintenance checks to help ensure print success. After confirming print readiness, the Fuse1 heats up to 180 degrees Celsius and coats the build area with a thin layer of nylon 12 powder. Our print process uses a laser to sinter layers of nylon 12 powder together to create exceptionally strong and functional parts. The non-sintered powder suspends the printed parts in place as they fuse, eliminating the need for printed support structures. After the print job is completed, the Fuse1 will let you know when the build chamber is cool enough to handle and remove. Industry-leading cooldown times allow for non-stop printer uptime, as you can swap in an additional build chamber shortly after removing the chamber containing the previous print.
In this case, the Fuse1 allows us to print on a production schedule to complete this job 3 times a week, yielding 300 consumer-ready nylon parts in a single printer.
I'll remove the build chamber and transfer it to the Fuse1. This all-in-one post-processing station combines part extraction, powder recovery, storage, and mixing within a compact footprint. Here you can watch as I unpack the build chamber and excavate the parts. The entire print rises up out of the build chamber into the Fuse1 work area, where I can then use the included cleaning tools to remove excess powder. The integrated vacuum and air filtration system ensures that loose powder is contained in the work area, keeping the post-processing experience both clean and tidy. Once we've excavated our parts, the excess nylon powder drains through the sift filter to catch any environmental contaminants that may have been introduced during the unpacking process. The sifted powder then enters a storage hopper alongside a separate hopper of fresh nylon 12 powder. When you're ready to start your next print, you can select a mix ratio for the reclaimed and new powders, which then automatically dispense into the powder cartridge below. The powder cartridge clips onto the integrated mixer on the side of the Fuse1 and rotates to ensure the 2 powders are combined uniformly. Fun fact, this blue component seen here is the mixer clip that we're printing today. Thanks to the innovative Fuse1 print process, we are able to print with recycled powder at a 30% refresh rate. This means that in order to start a print, you need to use only 30% new nylon 12 powder, and 70% can be reclaimed from previous prints using the Fuse1. This allows you to consistently produce high-quality parts using reclaimed material, cutting down on material waste and consumables costs.
During our extensive internal and external user testing, no degradation of mechanical properties was seen in parts printed with reclaimed powder, even after dozens of print cycles. The last piece of post-processing involves using a media blaster. This is an optional post-processing tool that is not included in the Formlabs workflow directly, but is a recommended tool for achieving a prime surface finish.
A jet of air and fine glass beads helps to remove excess nylon powder from the surface of the printed part. Finally, a burst of compressed air should be used to remove any stray blasting media that may have been left behind. If using a media blaster, be sure to keep it separated from your Fuse1 workstation, as blasting media can negatively impact the print quality of your nylon powder. So here we have a finished mixer clip ready for use. Formlabs engineers leverage SLS 3D printing in order to quickly iterate on the design of this component before committing to the final part for production. This saved both time and expensive tooling costs for the injection molded part that you see on the Fuse1 today. In addition to prototyping, we use the Fuse1 to manufacture components that are installed in the printers that we ship to customers, such as the IR sensor cone seen here.
Be sure to reach out to a Formlabs sales representative for a sample part like this and see if the Fuse1 can meet your prototyping or production needs. We hope that you're just as excited as we are about the future of SLS printing powered by the Fuse1 and Fuse Sift.